Like 1,6a to 1,8b is what's on your test. So we'll kind of go through each of the different kinds, and we'll put, little hints and stuff like that at the top to remind you how to do it. So for 1,6a, this is where we either factored and solved, okay? And there were all the different types of factoring. So this is not the easy factoring anymore. We had stuff like 1, where it was to the 4th and to the 2nd. And so your option here is to make these x squareds. And then find the factor of the first term and the factor of the last term just like you would normally do, okay? Or we could say a equals x squared, and we could make this a squared minus 37a plus 36. Factor it that way, but bring back in the x squared at the end. So those are your two options for the ones that have the 4th and the 2nd. When you get to something like 2, there's 4 terms. What are you going to do? Factor by grouping. And then when you get to something like 3, you definitely want to use your substitution. So remember, we're taking the middle terms parentheses, that 3x minus 2 to the 1/3, and we're replacing it with a. And in doing so, we get that a squared minus 2 times a minus 3 would equal 0. We're going to factor it, we're going to solve it, and then we're going to set it back equal to the a. Okay, so I'm going to start by factoring the first one. You can either do substitution or you could factor. I'm going to factor this. Find the factors of positive 36 that sum to negative 37, which would be negative 1 and negative 36. This becomes x plus 1, x minus 1, x plus 6, x minus 6. And then my solutions are negative 1, positive 1, negative 6, and positive 6. For 2, there was a typo that hopefully you corrected. This should have been a 2 here. And then we can factor by grouping. So I can take out an x to the 3rd. I get x squared plus 4. Take out a 125, and I get x squared plus 4. So then I get x squared plus 4 and x to the 3rd plus 125. Can't factor it, so I set it equal to 0. This would be negative 4. Plus and minus the squared of negative 4 would be plus and minus 2i. On the right-hand side, I would factor perfect cube. So cube root and cube root. So it would be x plus 5, x squared minus 5x plus 10. And then set this equal to 0. I get negative 5. For this, the a is 1, the b is negative 5, and the c is 10. I'd get negative 5, so 5 plus and minus the square root of b squared minus 4 times a times c all over 2 times a. 5 plus and minus the square root of 25 minus 40 over 2. 5 plus and minus the square root of negative 15 over 2. And I get 5 plus and minus I square root 15 over 2. So the solutions are plus and minus 2i, negative 5, and 5 plus and minus root 15 over 2. For 3, we're going to substitute. So we made a 3x minus 2 to the 1/3. Substitute it in, and I get a squared minus 2a minus 3. Factor this. A minus 3, a plus 1, set it equal to 0. And I get a equals 3 and a equals negative 1, but then this is my a. So 3x minus 2 to the 1/3 would equal 3, and 3x minus 2 to the 1/3 would equal negative 1. I'm going to cube both sides of these to get rid of the 1/3. I get 3x minus 2 equals 27. Add the 2. 3x equals 29. Divide by 3. And x equals 29 over 3. Over here, 3x minus 2 would equal negative 1 to the 3rd power is negative 1. Add the 2. 3x would equal 1. X would equal 1/3. So those two would be the solution. 29 over 3, and 1/3. 1/6b was all your radicals, okay? So first thing is, don't forget that these are the ones we have to check. So what my advice to you yesterday was, and I'll say it again, when you have ones you have to check, I would give yourself a circle, a star, or something when you go through your test, but go all the way through your test and then go back and check those. So we need to check anything that starts with a square root or a fourth root or any even root, okay? The odd roots are fine, but anything that starts with an even root, you got to make sure you check for an extraneous root. So on this page, I would make sure to check my answers for 1 and for 4. The square roots, I feel like, are the ones that people, square roots and the fractions at the end are the ones I think that people struggle with the most, okay? With the square roots, remember, you're either isolating a radical, right? So you're either 1, isolate the square root, and then square both sides. Or get 1 square root on either side of the equal sign and then square both sides. Because there might not be 1 square root. If it was a cube root like number 3, we're going to cube both sides. Yep.
So like for number 2, you wouldn't have to check out?
No. I mean, you check to see if your answer's right if you wanted to do that, but there's not going to be an extraneous root on an odd root. And then something like number 2, we would raise all of this to the 3rd power to get rid of the fraction. So you're going to raise it to the denominator's power. Yep. If when you plug it back in, what you're trying to find the square root of a negative number. So to check for an extraneous root, I would go to like these, let's say, and I would say that whatever's under here has to be 0 or positive. It could be 0 because you could square root it. And whatever's under here has to be 0 or positive. So you just want to plug it back in and make sure you're not square rooting a negative number. One 6b worked out. Now we've got those square roots. So for number 1, I'm going to move this to the other side. I'd get the square root of x equals 1 plus square root x minus 5. I want to square both sides of the equation. I get x equals, the shortcut here is square the first, square the last, and then double the product, which would be that 1 times the square root of x minus 5. So I'd get positive 2 square root x minus 5 plus that. Move everything except for the square root to the other side. I can combine these. This would be negative 4, and then add that to the other side, subtract the x. X's cancel. I get 4 equals 2 square root x minus 5. Divide both sides by 2, and I get 2 equals square root of x minus 5. Square both sides. 4 equals x minus 5, and then add the 5. 9 equals x. Because there's a square root in this, I want to check. I can square root 9, and 9 minus 5 would be 4, and I can square root that as long as it's positive. Going to 2. So I'm going to raise each to the denominator of my exponent, which would be cubed. 2/3 raised to the 3rd power would just be x minus 3 squared here, and 1/3 raised to the 3rd cancel out, so it's just 4x. Expand and FOIL this or use your shortcut, and you'd get x squared minus 6x plus 9 equals 4x. Subtract the 4x, and I get x squared minus 10x plus 9. Factors of positive 9 that sum to negative 10 are negative 1, negative 9. Split and solve here, and I get 1 and 9. I'm going to move this to the other side. And then I want to cube both sides. So I get 2x squared minus 4x plus 1 equals x. Subtract the x. When I multiply first times last year, I get 2. There are no factors of 2 that sum to -5, so I'm back to the quadratic. A is 2, B is -5, C is 1. -5 plus and minus the square root of -5 squared minus 4 times A times C, all over 2 times A. And I get 5 plus and minus the square root of 17 over 2. Go to 4. I got to move to the other side. So 4 square root x minus 3 equals 3 plus square root 4x minus 3. Square both sides. This is 16 times x minus 3. This would be 9 plus double that product. So 6 square root 4x minus 3 plus the square of this, which is just 4x minus 3. Distribute here. 9 minus 3 would be 6, plus 6 square root 4x minus 3, plus 4x. Get everything to one side besides that square root, so minus 6x and minus 6 and minus 4x, and I get 12x. And then these are all divisible by 6, so I'm going to just make it simpler. 2x minus 9 equals square root of 4x minus 3. Now you want to square both sides. Shortcut on the left, square the first term, square the last term, double the product. Subtract the 4x, add the 3. And then these are all divisible by 4, so go straight across. And I get x squared minus 10x plus 21 equals 0. That factors to x minus 7 and x minus 3. So my roots are 7 and 3. This time I want to check. If I plug 7 in here, that stays positive, that's fine. 7 in here, that stays positive, that's fine. So that one gets kept. And then plug 3 in, it's 0, but I can still square root that, plug 3 in, and it works, which means both the answers are in my solution set. 4. All right, then 1/6 was your fractions with the equal sign. So eventually we got to fractions with inequalities, right? This was equality, we got to fractions with inequalities, okay? This is an equation with a fraction or the absolute value. So with the fractions, with a variable in the bottom, you want to multiply everything by the least common denominator. So to find it, you're going to first have to factor everything. Then you're going to multiply everything by the least common denominator, okay? And these you have to check to make sure the denominator does not equal 0. So I'm going to check for 1 and I'm going to check for 2. Then for the absolute values, the absolute value equals a number. We set it equal to the positive and negative version of that number. Which means you should get 2 answers almost always, with the exception of if it was equal to 0. There were special cases in here, right? If it said the absolute value equals a negative number, this is no solution. Because the absolute value can never equal a negative number. And the ones with absolute value and squareds, you have to check. So number 4, I have to check. So if it has an x squared and absolute value, you have to check. Nope. Okay, 1/6 C, now we're dealing with our fractions with denominators that have variables in them. So the first thing we're going to do is factor. Then find my least common denominator, which is 2x minus 2, x plus 1, and x plus 2. So I'd multiply that times all of these. 2x minus 2, x plus 2, x plus 1, 2 minus 2 plus 2 plus 1. And this one actually here is right here. So here I can cancel out the minus 2 and the plus 1. I'd get 2 times x plus 2, or 4 times x plus 2. Minus, because the minus is going to come from there. Okay, so the x minus 2 cancels, the x plus 2 cancels, and the 4 gets multiplied by the 2 and by the x plus 1, but it's minus, so it's 8 x plus 1. Then I just realized this should have been a negative, making this a negative and a positive. So the negative cancels, the positive cancels, and the 2 cancels, and I get 3 times x plus 2. So 4x plus 8 minus 8x minus 8 equals 3x plus 6, negative 4x. These cancel, equals 3x plus 6. Subtract the 3x. Negative 7x equals 6. Divide by negative 7. X equals negative 7, or 6/7. Now to see, you got to check this, right? So to come back up here is the easiest thing to do. X couldn't have been 2, negative 1, or negative 2. Since it's none of those things, I get to keep that answer. All right, for 2, my least common denominator is 3x minus 2 squared. So this gets both. This is only missing one of them, and this is missing nothing. So I'd get 3 times, FOIL that out, it's 9x squared minus 12x plus 4 equals 2 times 3x minus 2 plus 5. Distribute. Subtract the 6x and the 1. 27x squared minus 42x plus 11 equals 0. Multiply, 27 times 11 is 297. Factors of 297 that sum to negative 42 are 9 and 33. 27x squared minus 9x minus 33x plus 11, and then factor by grouping. So I could take out a 9x, and I get 3x minus 1. Take out a negative 33, and I get, or sorry, negative 11. And I get 3x minus 1, 3x minus 1, and 9x minus 11. I get 1/3 and 11/9. From this, the only thing that x could not equal is 2/3. So I get to keep both those answers. All right, 3. Now we're dealing with our absolute value. So we're going to isolate the absolute value. At equals 7. So to get rid of the absolute value, we set it equal to the positive and negative version of that number. X equals 2. And negative 4/5. And the last absolute value 1, we're going to set this equal to the positive version of that and the negative. So positive 3x plus 6, and the negative goes to both, negative 3x minus 6. Combine my like terms or move them to the same side. 3x minus 6. So I get x squared minus x minus 6. Factor negative 3, positive 2, 3, and negative 2. Same thing here. Move to the other side. This is x squared plus 5x plus 6. And I get x plus 2 and x plus 3. And I end up with negative 2 and negative 3. Now we've got to check them all. So if I plug in 3, I get absolute value of 3 squared plus 2 times 3 equals 3 times 3 plus 6. 9 plus 6 is 15. Absolute value of 15 is 15. Equals 9 plus 6, 15. So that one works. Plug in negative 2, and on the right-hand side, it's the easiest way to check it. So negative 2 squared plus 2 negative 2, 3 negative 2 plus 6. I get negative 6 plus 6, which is 0. That still works. This negative 3, when plugged in on the right-hand side, gives me a negative 3. And since no absolute value can equal a negative 3, we rule out the negative 3. And I keep the 3 and the negative 2. Negative 2 just repeats, so I only need it once. Okay, 1, 7 was our inequalities, right? So now we've got greater than or equal to, less than or equal to. You're going to want to make sure you know the interval notation, because that's how you're going to give me the answer. For the beginning, remember, if we divide or multiply by negative, flip the sign. And then in here was our absolute value. So if it said something is less than or equal to, if the absolute value was less than or equal or less than, these were and statements. And if the absolute value is greater than or equal to or greater than, these are the or statements. For both of them, you put the opposite sign on the other side of the opposite sign number on the other side of the inequality. Keep the sign going in the same direction and then solve it. Just make sure you either split it for the or you keep it together for the and. So if I have negative 2x is less than or equal to 10, and I divide both sides by negative 2, I flip my signs. If I had positive 2x is less than or equal to negative 10, I'm dividing by a positive. Even though I'm dividing the negative by the positive, it's still dividing by a positive, so it doesn't flip. And then if I had like negative x is greater than 5, and I wanted to get rid of that negative x by multiplying by a negative 1, it's going to flip signs.
Wait, why doesn't it flip on the second?
Because what you're dividing by is positive.
Oh, so it has to
It's what you're dividing or multiplying by.
So if it's negative?
That's when you flip it. If the original number is negative, it's fine. But if you go to divide or multiply by a negative number, now it's wrong. And here's the thing. Like, if you second guess yourself, you can always check. Like, if I took an answer from here, x is less than negative 5. I'm saying like negative 6. I can plug it back in here. 2 times negative 6 is less than or equal to negative 10, and negative 12 is less than or equal to negative 10. It should be right. And then if you flipped it, it would have been wrong. You would have said your answers are greater than or equal to negative 5. If you plugged in 0 there, it would have been wrong. So you can always check it. Okay, 1, 7 was your inequality. Okay, now we're going to work out these. So for number 1, I'm going to distribute here. 2 minus 8x is less than negative 2x minus 6 minus 4. Combine your like terms. Negative 2x minus 10. You can add the 8x. 2 is less than 6x minus 10. Add the 10. And divide by 6. So 2 is less than x, or x is greater than 2. On the number line, it would be a 2, parentheses shaded right, which is how your interval notation looks. 2, I would add the 12 in all 3 spots. So negative 21 is less than negative 7, which is less than negative 14. Then I'm going to divide by negative 7. And in dividing by a negative, it flips my sign. So if I read this left to right, it would be 2 is less than x, which is less than 3, less than or equal to 3. So it's a bracket on the 3, parentheses on the 2, shaded in between 2 to 3 with a bracket on the 3. All right, 3 now gets into your absolute value. So this is absolute value is greater than negative 11. So it's an or statement. It would be 11 is greater than or equal to 1 minus 4x, which is greater than or equal to negative 11. Sorry, not which is. Or 1 minus 4x is greater than or equal to negative 11. So subtract the 1, 10, greater than or equal to negative 4x, divide by negative 4. Flips your sign, and I'd get negative 5/2. Or subtract the 1, negative 4x is greater than or equal to negative 12, divide by negative 4. X is less than or equal to 3. So on my number line, this would be x is greater than or equal to negative 5/2, and or x is less than 3. So negative 5/2, positive 3. This would be a bracket shading that way, and this would be a bracket shading this way, which means it's covering that whole number line, which if you go back and you think about it, absolute value greater than or equal to negative 11 makes sense. That would be an all real number situation. So negative infinity to positive infinity. Looking at 4, I'm going to subtract the 6. Divide by 9. And now this is greater than. So negative 5 greater than 3x minus 2, or 3x minus 2 is greater than 5. Add the 2. Divide by 3. X is less than negative 1. Add the 2. Divide by 3. And I get less than negative 1, greater than 7/3. So parentheses, parentheses, negative infinity to negative 1, union 7/3 to positive infinity. One 8A was your quadratic inequalities. So these we are factoring, solve, test points. So remember, it's either the ands or the ors. It's either out or it's in between. If it was a 3, if you had 3 answers, then it's every other. So all of these you'll do in a... All right, so looking at number 1, we're going to factor it. You can multiply the first times last, or you can do the trial and error, but 2 times negative 3 would be negative 6. Factors of negative 6 that sum to negative 5, negative 6, positive 1. 2x squared minus 6x plus 1x minus 3. And then I'm going to group this. Take out the 2x, x minus 3. And this one's already x minus 3. So x minus 3, 2x plus 1 equals 0. And I get x equals 3, 2x equals negative 1, and x equals negative 1/2. So now that's my test point. Zeros, and then I want to plug in, so the easiest thing to plug in 0. 2 times 0 minus 5 times 0 would mean 0, 0. Negative 3 is less than 0, so I know that section works. So I would shade it, parentheses, parentheses, shaded in between, and the interval notation, negative 1/2 to 3. Okay, looking at 2, you can either move the 121 over, factor, x plus 11 and x minus 11, and solve it, negative 11 and positive 11, or x squared would equal 121, x would equal plus and minus the square root of 121, and you still get the same answers. So now I get negative 11 and positive 11, plug in 0 again to here, 0 squared would be 0 is less than 121, and that works. So I get a parentheses on each of these, shaded in between, it'd be negative 11 to positive 11. For 3, I can do that same process. So square root both sides, put it plus and minus, and I get x equals plus and minus 2. Set up your number line. Plug in the 0. 0 squared is greater than or equal to 4. Not true. So I rule out the middle, put brackets this time, and point my arrows out. So negative infinity to negative 2, and 2 to positive infinity. And then the last one is 1/8b. This is where we get 1, right? Get it equal to, not equal to. Less than or equal to, greater than or equal to 0. So that's step 1. 2, combine any fractions. 3, numerator equals 0, denominator equals 0. 4, test your points. And then remember, if there is a variable in the denominator and it's greater than or equal to or less than or equal to, whatever makes that 0, change the bracket to the parentheses. So if you just looked at these examples right now, do you see something that has a variable in the denominator that has an or equal to statement? Which one? 1, which means when I go to solve for 1, whatever makes this 0, which is negative 4, instead of it having a bracket, is going to have a parentheses. So whatever's on that negative 4, whether it's pointing left or right, it's going to be parentheses instead of a bracket. Okay, and then the last one. So for here, I need to move the 1 to be on the other side. 2 over x plus 4 minus 3 greater than or equal to 0. I need to give this a like denominator. So 3 over 1 becomes x plus 4. 3x plus 12 over x plus 4. So 2 minus that, which means both signs are going to change on this and this. So negative 3x minus 12, all over x plus 4. Negative 3x minus 10 over x plus 4, and then split and solve. X equals negative 4, negative 3x would equal 10, and x would equal negative 10/3. Now, those are your test points. This is negative 3 1/3. Negative 4, negative 3 1/3. 0 is on the right this time. Plug the 0 in up here. So 2, 0 plus 4 is greater than or equal to 3. 2/4 and a half is greater than or equal to 3. False statement, so I rule out that part. And I would grab, it's every other, so I'm going to grab the in between. Now, because this is in my denominator, we said it before, but x cannot equal negative 4, which means there's going to be a parentheses on this one and a bracket on the other. So I get negative 4 to a negative 11/3 with a bracket, or 10/3, sorry, a bracket on the 10/3 and a parentheses on the negative 4. So I go to 2. Same thing, I need to make 2 over 1 become something over x minus 1. I'd multiply by x minus 1, 2x minus 2. The minus is going to go to both of those things. So 3x plus 1 minus 2x plus 2 over x minus 1. X plus 3 over x minus 1, split and solve. X equals negative 3 and x equals positive 1. Set up your number line, plug in 0 up here, 3 times 0 plus 1 over 0 plus minus 1. Minus 2 greater than 0, so 0, 0, 1 over negative 1 minus 2, negative 1 minus 2 is negative 3. That is not greater than 0, so I rule out that section. That means I'm taking the outside. It is greater than, not greater than or equal to. So I'm going to get a parentheses on the negative 3, point it left, parentheses on the positive 1, point it right. So I get negative infinity to negative 3, and then 1 to positive infinity. And the last one is already equal to 0 or less than 0, so the bottom just has to be factored. split and solve, and I get x equals -5, -2, +2. Set up your number line. 0 is in here. Plug in the 0. 5 over -4 is -1 1/4 or -5/4, which is less than 0. So I get to keep that section, which means we're doing every other. That section, skip the one to the right, the one to the left, and the last one would be over here. It gets parentheses, -5, parentheses, because it's not or equal to, and then from -2 to +2. And that's all the warm-ups completed.